This conference will now be recorded.
Guys, in previous session, what we have discussed like how a, a particular chat GPT like application is working. So broadly, what we have seen, there are two main steps: pre-training and fine-tuning. Okay, let me write it down. Pre-training and fine-tuning. These are the two steps once we are talking about an application like ChatGPT. Okay, over here, inside the pre-training, that is providing us a fundamental model, or you can say foundation model. Foundation model is given by pre-training, by this particular phase. Then on top of this, what we guys are going to perform, we are going to tune it further in order to get the more optimized result. So that is nothing but a tuning the weights, or tuning the weights, or changing the weights, changing the weights. Okay, so over here inside the pre-training phase, we are getting certain weights and how these particular things are happening in the back end. So I'm going to explain those particular things. In today's session, we will be having the discussion about these two things: pre-training and fine-tuning, and internal about the pre-training and fine-tuning. Okay, so let me try to show you certain diagrams through the presentation. So over here, guys, what we are able to see, we are having a particular data, and it can be in terms of text, image, speech, structure data, 3D signals, whatever we are having, that is categorized under the data field. Now, on top of this particular data, we are going to perform the pre-training. This training is nothing but the pre-training, and what we got from the pre-training, that is nothing but the foundation model. Okay, now we got this particular foundation model. On top of this, in order to optimize the behavior, optimize the output, we used to perform the fine tuning. Okay, in the next phase, what it will be, the fine tuning will be done on top of the foundation model. And exactly what we are getting inside the foundation model, we got weights with respect to the tokens. Like tokens are having uh, connection with another tokens, so those are categorized with respect to the weight. And once we are performing the fine tuning, that weight is keep on changing. How the things are happening internally, that we will see. Okay, so once we are for this particular step, we used to perform the tokenization. So tokenization is a process where the text is converted into tokens. Okay, so over here a definition is given, like tokenization is a process of breaking the raw text into the smaller units, called tokens. But how exactly is uh, this particular step is happening? So say over here I'm having a particular uh, sentence, I'm learning AI. Okay, so this is a sentence, and if I'm going to break it into tokens, so token, it might be possible I, then the inverted comma is a token, m is a token, learning is a token, AI is a token. Okay, so the this particular sentence is broken into the tokens, and then a particular token is having a token ID. Okay, so in this particular way, the data, the inputs that you are giving is converted into tokens, and tokens are mapped with a token ID. If like I is given 100 times in in a paragraph, then each and every time I will be having the same token, that is nothing but the 45. Now you might be wondered like how this tokenization is being happening and what is the criteria. Okay, so once we are talking about the tokenization process, then there are multiple level of tokenization. What I can say, tokenization and breaking, that is nothing but breaking the words or the sentences into smaller units called tokens. Okay, so this is nothing but the tokenization. Now, how this particular breaking will happen? What are the different mechanism based upon that I will be able to break a particular sentence? So this you can say breaking of you can say sentences can be possible into the different ways. Say I am learning AI. Okay, you can take this particular sentence, and if you are going to break this particular sentence, there are n number of you can say ways, but there are certain things like criterias which are opted by the industry. So based upon that, we guys are going to perform the tokenization. So first one is say word level tokenization. Okay, so what I will do over here, I will break each and every, I will break this particular sentence, and each and every word will be a token. So for me, over here, if I'm going to have this particular sentence, so what I will get, I am learning and AI. Okay, so what I will get at this moment, four tokens, right? Is it clear? I got four tokens. Word level
Fine, sir.
tokenization, is it clear with everyone? Guys, can you
Yes, sir.
confirm?
It's clear.
Yes, sir. Yes, sir.
Perfect. So this is nothing but word level tokenization. Now, sub word level tokenization. So what will happen at this moment? Okay, I will perform the tokenization based upon the subwords. So if I am having this particular sentence, so how I will be able to break it? Uh, so just have a look. So I can break it into based onto the subword level. You can think in this. Let me complete first, then you will be able to get. Okay, so I am, and it might be possible learn and ing will be taken as a different token. So what I will get at this moment, how many tokens? How many
Five.
I.
tokens? Five tokens. Okay, five tokens. Now moving further, what I can have character level tokenization of breaking the complete sentence. Breaking the sentence is based upon the character. Okay, so at this moment, if I'm having this particular sentence, so what I will get, I am Okay. So how many tokens are there at this moment?
It,
Mm-hmm.
it's 13.
So what I will have, this is, let me
Twelve,
mention,
12, 10.
this is the first token. Okay. And then this is the second token, second, then this is the third one, then this is the fourth one, then fifth
30.
one. A is coming again, so this is the second. R, then sixth one. N is there, then seventh token. I is there. I, okay, so eighth token. N, so this is the seven one. Okay, you can say I'm giving the token ID to these particular tokens, and based upon that, I will be able to get like the unique tokens. How many unique tokens are there? Right?
Yeah.
Okay, A is there, say 10, and I is there, then first. So unique tokens, I will have 11 unique tokens at this moment. Okay, 11 unique tokens. Okay, now you
11
need
or
to tell
10
me.
sir.
Sorry, 10. Okay, so 10 tokens are there. Now,
Sir, I
can
three
you
times repeated na?
come again? Yes,
I three times repeated.
this is L, learning.
No, no. Learning I.
I is over here. This is the capital one, and this is the smaller one. Both of
Okay,
these will
okay.
be having the different tokens. Okay,
Understood.
okay, perfect. So now you need to tell me, all of you, just pay attention over here. Uh, Over here, I'm having four tokens based upon the same sentence. This subword level has given five tokens, and the character level has given 10 tokens. What will be the impact of this? What is the impact of this? What you are able to get over here? Hmm. So I have, let me give you a hint. Okay, over here vocab is there. What is a vocabulary? Just read it, and then you need to tell me what is the impact of the tokenization scheme, and how we will be able to improve our productivity, or how we will be able to optimize our code based upon this vocab, or how we will be able to improve the tokenization process based upon the vocab. Hmm. Just read it, and then you need to answer what will be the impact of
Memory size will be affected and performance will also degraded.
how.
Just because number of tokens will increase, so
Mm-hmm.
consequently, the memory size will be more optimized.
uh, that is fine. Perfect. So what exactly is being happening, guys? Once we are going to perform the tokenization, so words or the sentences what we are having, those particular uh, words or sentences will be passed, and it will be passed uh, from the vocab. Vocab is having all the sentences, or all the words. The vocab is nothing but the complete all the words, the combination of all the words that our tokenization algorithm is sporting. So say, let me try to show you over here. If you are able to see, Okay, so if you are able to see over here, the different algorithms are there, say GPT-4o and GPT-4o mini, GPT 3.5, GPT-4, GPT-3 legacy. Yeah. So these particular algorithms, these particular foundation models, not the algorithms, what I can say at this moment. So these particular models, foundation models, are having different tokenization scheme. So over here, so if you are able to see the tokenization scheme what we are using over here, the tick token, then inside the GPT 3.5 the tick token is there, inside the legacy. I'm learning AI, so legacy has given us 4 tokens, and token ID is text token, tick token is there, 4 character. Just a minute. I'm having the presentation. So these particular things I have mentioned, I have mapped inside the presentation. Let me try to show you. Okay, so over here, if you are able to see GPT-3, that is from the OpenAI, that is from the, you can say, OpenAI. And over here, the tokenizer, what it is using, the BPE, byte pair encoding. Byte pair encoding. So I'm not able to see why it is not changing once I'm clicking onto the GPT-3 and 3.5. But yes, different tokenization scheme, different tokenization type has been used in 3.5, GPT 3.5. Inside the GPT-4, what we are having, the tick token. So based upon the schema tokenizer type, what we will be getting, the vocab size. So 50,000 to 57, this is the vocab size once we are using BPE tokenizer scheme, especially for the GPT-3. And once we are having GPT-4 and 3.5, like BPE is utilized and the vocab size will remain same. And this is nothing but the tokens, max token context, that is like how many tokens it is able to retain in memory. Let me try to show you what is the meaning of this. Say I have opened this GPT prompt. Okay, so just have a look over here. I have searched with respect to the quantum computing and all. Okay, and if I'm going to search like how many bits, how many qubits are there in IBM Q? Okay, how many qubits are there in IBM Q? So it is saying IBM, with respect to IBM quantum processors, these are the number of bits which are available, like 127 qubits, or 433 qubits, or 1121 qubits. These are the plant, and the IBM Falcon 25 to 65 qubits. So these are nothing but number of bits which are available for a quantum computing processors. Now, what I'm trying to say over here, I have, why I am able to get this particular output, because I have searched with respect to this. This is nothing but the context. Like if I'm able to retain context. So if over here I can pass inside the different models, say if I'm taking GPT-3, so I will be having maximum 2049 tokens at this moment over here. So whatever the prompt I'm giving, so it will be able to take 2049 tokens, like this particular sentence, these particular sentences, whatever I'm going to type over here will be converted into tokens, and based upon that 2059 tokens only, it will be able to provide the outcome. Okay, just a minute. So this is nothing but the context. It is able to retain the context up to 2059 tokens. It will be able to provide the output based upon the context length which is given by a particular model. If you are able to see GPT 3.5 or GPT 4, these are having you can say high amount of context, like GPT-4 is having 4K, 8K, but 8K and 32K is given with the paid versions. Onto the free versions, you will not be able to get 8K token context. So this is nothing but like how a particular model will keep the tokens inside the memory and provide you the outcome with respect to this. Our main motto, what is our main motto, that based upon the tokenization scheme that you are using, uh, the the vocab sizes keep on changing, and if the vocab sizes keep on changing, then what will happen, whatever the sentence we are giving, that will be passed from that particular vocabulary in order to get the token. Okay, so vocab is nothing but all the possible tokens in a particular language. Okay, so over here language, I'm not talking about language but the scheme, tokenization scheme. So this BPE tokenization scheme, whatever we are going to type, what it will do, it will pass the sentences from the vocabulary and provide a particular token. Just have a look, and then I will explain it once again. Okay, so let me copy this and paste it over here, and say hello, 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 hello. Okay, so over here, just in order to give you a particular reference, so I have used hello over here, that is used 4 times, and with respect to each and every hello, 40617 token has been given, token ID has been given. And if I'm talking about the text, like how the tokenization is being happening over here, open AI, open is one token, so it is working based upon what, which tokenization scheme is utilized over here? Which tokenization scheme is utilized over here? Word, character,
Word
or
level.
subword?
Word.
Subword.
Subword.
Subword. So just have a look over here. Open is open AI. That is a single word over here. But what we have done, open is a unique token. AI is another token. Comma S is taken as another token. Large language models process text using tokens. Okay, so in this particular way, whatever the sentence I have typed, whatever the paragraph I have given, so it has converted it into the tokens. But how these particular tokens are being generated based upon the vocabulary. Okay, so I have taken GPT-4o and GPT-4o mini. So that is having tick token algorithm in order to, you can say, convert these particular words into tokens. And based upon the vocabulary, it these particular, you can say, words are passed. First of all, like, these are divided into, you can say, tokens. And then once these are divided into tokens, then based upon the vocabulary, we will be able to get the token IDs and all. Okay, so these tokens are from the vocabulary only. And the vocabulary will be having all the combinations, like from this particular language, say, in this particular, say, in from the English language. And once we are using BPE tokenization scheme, then we will be having 50 to 257 50,000, almost 50,000 tokens are there. And this particular tokenization is different with respect to the different, you can say, tokenizer. Okay, so over here, llama, that is the sequence piece unigram. It has used the sequence piece unigram tokenization type. And over here, vocab size is 32K, and the tokens are, the max length is 40K, 4K. So the vocab size has been reduced. Tick token over here, like that is the modified BP. And 1 lakh plus tokens are there, and the token length is also increased over here. Llama 3, Llama 3, that is the sentence type, sentence piece unigram again. And the token vocab size is 128K. And the max context length, what you can say, context length is 8K to 32K over here. And with respect to the different models what we are having, so different vocab size is there. And based upon the vocab size, the tokens are being generated. And these tokens, this vocab size is playing a critical role once the token IDs are being generated. And it is having a positive impact onto the performance, okay, performance of a particular model, right? Clear? Is it fine so far? Anything, any doubt, friends? Anything that you are not able to get?
Fine, sir, fine.
Anyone having any doubt? Okay, so just have a look onto the different algorithm or schemes what we are having. White space based, splitting the data based upon the white spaces. White spaces or split based upon the spaces. This particular stuff is used by the NLP task. And prawns, that is of simple type. And cons doesn't handle the punctuations and causing up, like how the tokenization is being happening, dividing the sentences into words. How that particular stuff is being happening, there are different levels, character level, word level, sub word level. Majorly we guys are working with these particular stuff. Okay, sub word, that is nothing, BPE, byte pair encoding. Okay, so what we have discussed, like inside this GPT 3, GPT 3.5, BPE is the scheme that has been utilized. And based, because of that, like the vocab size is almost 50K. And we are having different context length based upon the algorithm. Okay, but you just need to focus onto the how the sentences are converted into tokens. And the tokens are then converted into token IDs. And based upon that, we are having a particular vocab size. And this vocab size is playing a critical role once we are going to create the parameters. So over here, let me show you something. Okay, so I have opened the models and say llama. Okay, so over here what we are able to see, friends, the 3 billion, the 70 billion, okay, 8 billion, 70 billion. Okay, so these are nothing but the parameters a model is having. More the parameters, more the accuracy. Okay, more the parameters, more the accuracy. Or you can say, if the parameters are more, then uh, the model will be able to provide the diverse result. Like it will be able to provide the outcome with respect to the different domains. Like it might be possible you have trained a particular, you have trained a model with respect to small set of data, and based upon the small set of data, the parameters what we will be able to get, those will be less, and the outcome will be with respect to the data which is utilized in the pre-training phase. So more the parameters, more the accuracy, you can take it in this particular way. But that is further enhanced with the help of fine tuning and all. So those particular things are also mandatory. But more the parameters, better the accuracy, you can take it at this moment. Because like we will be having huge, or you can say, a lot of dependencies with respect to each and every word to another word. We will see, but at this moment I'm not going in detail. But what I'm willing to say that once we are going to perform the tokenization and all, then this is a way the sentences are taken. These sentences are broken into different levels. It might be character level, it might be possible subword or word level. So industry is preferring the subword level tokenization scheme, and based upon that particular bifurcation, we will be getting a vocabulary. And vocabulary size is going to create a model. And the model parameters are impacted based upon the vocabulary size. And this particular calculation, like how the vocabulary size is going to impact the model parameter, that we will see. That you can park at this moment. But vocabulary size is very important once the parameters of a particular model is being calculated. So over here, how we are able to get 3 million, 70 billion, that we will see with the calculation. But at this moment, like the 50k tokens, how these are coming based upon the spotted words, or inside the English language. So we are having the combinations and all. So based upon the combinations, the sentences are broken into the tokens, what I can say, or subword. And those particular subwords are nothing but the components of vocabulary. Okay, and cumulatively all the subwords is considered as a vocabulary. Okay, is it fine so far?
Yes, sir.
Fine, sir.
Any confusion, friends? Anything that you are not able to get?
Till now it is fine, sir.
Okay, perfect. So tokenization is possible onto the different level, and subword level tokenization is more famous inside the industry. Even like in chat gpt like model, the subword level tokenization scheme is being utilized. Moving further, in the last session what we have seen, say we are having llm, then llms, or what I can say, large data. Large data, this we have discussed in our previous session. Okay, so over here what we have done, on to the large amount of data, I have done the pre-training, and pre-training has given what? Pre-training has given large language model. Okay, and this large language model is nothing but the foundation model, or base model. What I can say, base model. So we got the base model. Now what I will do, I will do the fine tuning. Fine tuning. So fine tuning, say user is sitting over here, and what he will do, he will pass questions. So the user will pass questions, say thousands of questions, thousands of questions. Basically, like in order to train the model, like, or fine tune the model, that outcome will be given in this particular way. It is given. It is question and answer. What I can say, question and answer are given. So over here, thousands of questions and answer are given in order to train, in order to fine tune this particular model. And once the fine tuning is being, once it is done, then the user will be able to get the correct result. So over here, what we got? So we got the weights. We got the weights. Base model is having some weights, and we tune these particular weights based upon these question and answer, and then we will be getting the fine-tuned output. Let me try to show you certain diagrams. uh, Tuning of weights in Gen AI. Okay, so just have a look over here. We are training the model, and then release weight, replicate behavior, fine tune the model, and build new application. This is nothing but with respect to the steps what I have mentioned over here. Like large data is there, we have done the pre-training, we got the base model that is having certain weights. Over here, so release weights is nothing but we are having certain weights. Now what we do, replicate behavior. Replicate behavior is nothing but providing the desired output. Like I just want that the model should give the outcome in this particular way. If I'm asking a question, then the model will provide me the answer. Okay, so thousands of question and answers are given, then uh, it will be tuned, and we will be having the tuned, you can say, weights, and then we can build applications, or we can get the outcome, okay, from that particular model. So this is nothing. And if he has shown picture really, let me try to, okay, probably you will be able to get with the help of this example. Okay, so we are having certain data, number of parameters, memory footprint, pool. Okay, it is a little bit complicated for you all. Okay, let me try to provide with the help of an example. Say I'm having a particular, say, what I can mention. mm, Please prepare a cup of dash for me. Okay, so I'm having this particular sentence, and over here what I'm willing to get, I just want to fill the blank. Okay, fill the blank, and I just want a correct outcome over here. Okay, now now what will happen, say once this particular model is pre-trained. So first step, what guys, just pay attention over here, this is very important in order to get the internals how things are happening in Gen AI. Okay, so the first step what it will be, like this particular sentence is converted into, say, tokens. So this is a first token, and this particular, this is the second token, second, and I'm giving the token ID, say, this is the, say, third token, and this is the fourth token, and fifth token, and then sixth token. Now over here, okay, over here, this particular you can say sentence, and these are the tokens. Now once this is, you can say, given inside the pre-training phase, then what it will do, it will assign a particular weight. It will assign a weight, say it is 1 dot, you can think in this particular 0.4, it will be in terms of certain weights are given. Say one is having this much weight, and two is having, say, this much weight. Okay, it might be possible the weight is negative. The Okay, the words which are not, you can say, required, that can have the negative weight, like which are not having any impact on this particular sentence, those can have the negative weight. So it might be possible the first, you can say, have the negative weight. The is the word, okay, or token. If I'm removing this, no major impact will be there onto this particular sentence. So the weight, probably, say, the pre-training phase has given this much of weight. Prepare is having, say, this much weight. A is, say, having less weight. Okay, okay. Then cup, cup is having, say, weight for this particular sentence 991, and for me is, say, possible, have negative weight, say 00 minus 0.0001, and me, this I can take in negative. Okay, I'm just moving hypothetically. Okay, so these are nothing but based upon the pre-training, we got certain weights. We got certain weights. Okay, clear so far?
Sorry to interrupt, like how system will define when to give negative and when to give positive?
System will go through with the sentence. Okay, and based upon the sentence, uh, it is try to analyze, and if a particular, you can say, word or token is not having the impact, have it will try to map each and every word. Okay, each and every word, like, so the prepare, it will try to find the relationship between each and every word. Okay, the will be mapped with prepare a cup for me. Okay, so it will be mapped with the all the words or all the tokens. Prepare will be mapped with all the tokens. A will be mapped with all the tokens. Okay, so once it is able
Can
to
we
get,
take can we take in this sense, like if a statement is having any pronouns, nouns, then it will segregate onto basis of that. Like if the adjectives are not used, so we can provide negative to that. If nouns
No,
are
no, no,
useful,
no,
they will
no, no,
provide positive to
no,
that.
no. In the natural language processing, in the NLP stuff, we used to follow that particular mechanism. But over here, we need to retain the context. Say we are talking about a particular patient, and if patient, with respect to the patient, the nouns or pronouns has been, you can say, removed. Okay, then it will have a major impact onto the outcome, right?
Okay.
So
Mm.
over here we try to find the relationship between each and every word, whatever are mentioned, and based upon how one first, like, it is trying to identify. Okay, so based upon this, like, it is identifying the relationship, and it is providing the initial weights, initial weight to a particular sentence, to a particular token. You can take it in this way, based upon its understanding. Then the fine tuning will come into the picture. Okay, and for the fine tuning, what will happen, this will be, you can say, passed with, you can say, certain third party application as well, if required. Okay, and then the weights, these particular given weights are being tuned. Okay, say the please, instead of the prepare a cup of tea, let me mention, please prepare a cup of no, cup space for me. Okay, so now this please can have, it can change this particular, uh, it can change the meaning of this particular word. So please will be having the high impact onto this particular, you can say, sentence. Okay, so at this moment the weight for this, say, first token will be positive. What I can say it might be possible 83434 is given. So, like, please, that is nothing but like his pleasing, or his just asking a favor. Okay, you can take it in this way. If, like, prepare a cup space for me, so it might be possible he is ordering. The sense, the context is being changing over here, right? The context is being changing. So what I want to say, initially, if a particular sentence is given, that is broken into the tokens will be having certain weights, and now the fine tuning will come into the picture. So what it will do, it will pass these particular tokens, uh, in the vector db. It will pass these particular sentence tokens in the vector db, and based upon the vector db outcome, like search is being happening at this moment. So what it will provide, say, over here, say, please prepare a cup of tea for me. Okay, and then it might be possible over here, it will provide multiple output. You will get multiple output. Okay, so prepare, and it might be possible the weights. Okay, so the weights are being changing at this moment. So say 40, it might be possible prepare, it is 5. Okay, and then over here the tea is having, say, for me, cup of, and say tea is having this much of weight, and instead of tea, say, prepare a cup of milk, prepare a cup of juice, okay, and prepare a cup of water. I'm just typing, okay, and all of these particular sentence, say over here the weight is say 8801. These weight also change. I'm not. I have not changed. Say 9236333. Okay. So in this particular way, the weights are keep on changing, and the output which is having the highest weight, okay, that will be taken. Like prepare a cup of tea, and how we are getting this particular outcome based upon these particular weights. Initial we are having certain weights, and then we will proceed with the fine tuning and all, and there are certain steps as well, no need to worry, but fine tuning is going to modify the weights of your output, and not output but intermediate output, and once we are having an output which is having the highest weight, that will be considered as the final output. Hopefully you are able to get on a broader level, like how the things are happening. Initially we are giving certain weights, and then we are fine tuning, optimizing those particular weights with respect to the stored information, right? Stored information, the vector db, okay, so where we are going to store the information inside the vector db, okay. So that is the stuff which is happening, and these particular things will be happening in a matrix form. I will drill it further in order to, like, say we will take an example, and then we will prepare a matrix, and then we will try to do the calculation of matrix, how mathematically things are happening in the back end. So those particular things I will cover, but at this moment what I'm willing to say, that pre-training is assigning certain weights, and in the fine tuning phase those particular weights are being modified or optimized, and we will be getting a number of inputs, but based upon the output which is having the most suitable weights or most suitable probability, what in different words, okay, so that will be taken into consideration, and that will be given as an output. Okay, just have a look and ask if you are having any doubt. Anyone?
Reposition also having tokenization and weightage.
Come again? The position?
Repositions, yes, like full stop, question mark.
Prepositions? Okay. No, no, no,
Yes.
no, no.
Okay.
Anything?
No, thanks. We can proceed.
Okay, perfect. Let me try to. Okay, so just have a look over here. Uh, I will cover these particular things. Okay, so what I'm betting, I will refer this particular tutorial in order to provide you the internals, like how, say, man, woman, boy, girl. So certain mapping is there, and relationship is there. Say if I'm and this relationship, please just try to, like, we are having, say, different dimensions models, okay. Over here, say if I'm talking about 2D model, say x and y and gender and age, if 2D model is there, so and boy and man and girl and woman, so they are having certain relationship, So we mathematically we will try to identify that particular relationship, and based upon that, like we will proceed with the calculation. So so these particular things we will learn. Okay, so we will cover all of these particular things. What I want to show. I'm looking for one thread that I want to show you. Just give me a minute. I'm trying to find it. Mm-hmm. Okay, in next session I will tell you about that. Okay, so what we have discussed, like how the pre-training and fine-tuning is happening, and at the back end the data, the sentences are divided into words or subwords, and then the tokens are given. The token are assigned with a certain weights, then that particular weight is fine-tuning, and it will be the iterative process. Friends, like this weight assignment, it is an iterative process because it is passing from from the neurons. So we will be we have seen the transformer architecture, and inside the inside the deep learning, like neurons are there, and this particular weight is keep on changing, and at the end, like after passing from the all the layers, we will be able to get the optimized output. So what I want to mention over here.
Uh, Sir,
Mm-hmm.
sir, I have a question that
Mm-hmm.
you told us that as according to different inputs, the weightage is divided as according to the AI. So how AI is comparing all weightages and giving us the appropriate output?
So the main stuff over here is defining or assigning the initial weights, that we will get from the base model. What I can say, foundation model is going to provide us the base weights, initial weights, with respect to the tokens what we are having, and these weights are based upon the relationship of each and every word with respect to the others. Okay, so if we are talking about this, you can say chat gpt, this is multi-dimensional model, and or multi-dimensional model, and in different dimensions we are trying to identifying a relationship, like say cup is heavily dependent, or is having uh, high relation with respect to tea, okay, cup of tea, okay, so that weight will always be high, right? So initial weights are given from the base model or foundation model, then based upon the context what we have given, it is not like say whatever we have given, or a particular organization say which is providing the coffee, so over there the cup uh, is more related to coffee, that is having more, you can say, relationship with coffee, right? So at that moment the data is changed, the weight will be changed, and it will provide the correct output, huh? It is not like say we have pre-trained it based upon certain data, but once we are coming to the fine-tuning phase, then we are having the the authority, or what I can say, we are having the power to change the weights uh, with respect to like fine tune a particular model. Are you
So,
able to
sir, I
get
hope that there would be any formula to calculate the weightage of the data.
that? We will
Right.
see.
Mhm.
I told you like hypothetically at this moment I have mentioned like say things are working. I have shared this particular thread over here. The weights and all these particular things are calculated, huh? Right? Grandfather, man, woman. Okay, so these are the weights which are given, and how you will be able to get these particular weights we will see mathematically, right? Definitely there are formulas, huh? Right?
Yeah, got. And one more
Okay.
thing, that there you told me that there are three different ways to tokenize every
Mm-hmm.
sentence. So,
Mm-hmm.
what are the scenarios that every AI is using any of the tokenization? Like you show us that that GPT is using tokenization as according to the keyword. So, in what
Mm-hmm.
scenario that it can be used the tokenization as current depend on the character or the words?
So so that is coming inside the pre-training phase, huh? Okay. The stuff what I mentioned like pre-training, that is the you can say the phase where a huge number of infra and the cost is involved. So at that moment they have they are having, you can say, they have identified like this is the tokenization scheme and this is the stuff, and based upon that they are moving. If they are not able to get the desired output, like it is the output, whatever we are getting, that is the output of multiple iterations. It might be possible they have done it with say subword level, or word level, or might be character level, okay. So what we got at this moment, that is nothing but the output of all those iterations, and this is nothing but uh, an optimized, you can say, foundation model, huh? Right? And uh, you can take it in this way, like different machine learning algorithms are providing different accuracy on different type of data, or different domains organizations, or different organization data. Say I'm using the random forest, and I'm working onto the say telecom data, it might be possible that is providing me better accuracy. But if I'm using the random forest onto the financial data, it might be possible that accuracy is less at that moment, huh? So if the accuracy is less, definitely I need to go with the different model. Okay, so based upon the data set available, they have gone through with different tokenization mechanism, and the output what they are able to get, uh, which is the better one, and they have finalized that particular tokenization scheme. So because of that only, like there are different tokenization schemes into the different base models or foundation models, right? It is not like each and every base model or foundation model is trained on same type of data. Some of them have used, say, uh, data in terabytes, and then output is, say, in GBs. Some of them have used the data in GBs and output in, uh, say in you can take it in the, say, thousands of GB has been taken, and hundreds of GB is the output, right? So different algorithms, different tokenization mechanism, different domains data. So a lot of things are considered, and because of, and these are the initials, friends. These are the initials. Based upon these, you can say, fundamentals only, we will be able to reduce the cost as well. It might be possible they have moved with, say, the vocabulary with 1 lakh combination, 1 lakh size of the vocabulary, but it might be possible if they have gone through with, say, 50K vocabulary, they might have the better performance. But probably they have not gone. I'm not commenting on that particular stuff, but different fundamentals can change the model cost, and that's what the DeepSeek has done. uh, I'm quoting an example. So chat gpt and this bart, or Gemini, what I can say, bart and Gemini both are the same thing. These are the LLM models from the Google. So once they have trained, they have taken huge resources, and the cost was in, you can say, millions of dollars, but the DeepSeek one, when the DeepSeek, it was, you can say, came in Jan 2025. Okay, and they are able to provide the same accuracy, and they have used less amount of infra, almost, say, 100 times less infra, and 1,000 times less cost is taken in order to train the DeepSeek model. So what they have done, they have changed the fundamentals, right? So it might be possible, like, say, different coding or tokenization mechanisms are there, but at this moment what they have given based upon their data and all. But yeah, tuning is always possible, optimization is always possible, and this optimization can lead to reduction in the cost as well, and that's what the outcome we can see as a DeepSeek application. You can Google DeepSeek. Let me try to show comparison of DeepSeek and ChatGPT. Yeah. Okay. Let me ask with ChatGPT only.
So sorry to interrupt.
Mm-hmm.
So I a question came into my mind, like when we are searching, I want a dash cup for me. So
Mm-hmm.
how this ChatGPT is selecting the pre-training data from the net? Like according to what I can understand, it will be getting some data from Google or somewhere
Yes,
from
yes.
sites.
So what they have done, they have taken the data from internet and all. Okay, pre-training is, just have a look onto this, onto this particular stuff, large data. So whatever the data available, it might be, so wiki data, different search engines data. Okay, whatever is freely available, they have taken that particular data. Okay, and on top of that data, the pre-training is being done, right?
So then every time it has to collect the complete data, like
No,
the
no, no,
question
no.
which we
Yes,
are
I,
asking,
I
that is
will
not
come on to
specific,
that
right?
point. I will come on to that point.
Hmm.
Okay,
Yeah, sure.
okay. So just have a look, friends. Over here, Origin, OpenAI, US, DeepSeek, base models are this one, primary focus, GenAI, general purpose coding and all. Okay, pricing, okay, GPT, 1 billion tokens, infrastructure and hosting. They have not given. So it has given the outcome with respect to. Okay, DeepSeek and ChatGPT both are both powerful AI language models, but they excel difference. DeepSeek is particularly strong technical writing, logical reasoning, and data-driven tasks, often offering more affordable and efficient solutions. Specialized application, and then like what I want to show, not strength in terms of cost in pre-training. Okay, DeepSeek generally offers more cost-effective application. DeepSeek's R1 model, for example, estimated training cost is 6 million, where ChatGPT cost range from the 100 to. Just have a look over here, friends. Okay, 6 million, 100 to 200 millions, training cost, right? Are you able to get? So fundamentals are playing a critical role once we are talking about Gen AI and all, right? Although like these particular things are not mandatory, what I'm covering, but because like we are learning new stuff, and if we are not having the information about base, then we will not be able to build application on top of this. Okay, we will not be able to optimize it. We must have the understanding about the fundamentals, and that's what we are learning, right? Fine, is it fine?
Yes, sir.
Yes, sir.
Yes, sir.
Perfect. So so one method, what I have mentioned over here, in order to fine tune, we provide the question and answers to the base model or fundamental model. It will learn based upon these particular questions, and then start providing the output with respect to this. Now, there are the specific, or you can say some organizations which are performing this particular task. This is not the fine tuning is not you can say taking too much resources, uh, but like these particular question and answers required the domain expertise related stuff, and the organizations which are going through with the pre-training you can sorry, fine tuning stuff. They are specialized, you can say, in order to perform those particular tasks. So specialized organizations are performing this fine tuning stuff, and small number of organizations are going to perform the pre-training. It is not like say each and or every organization can perform. It is involving the huge infra and cost. Okay, but fine tuning is not having that much of infra, or cost is not so much cost is not involved over here. Now the question, like, how often we need to do pre-training, and how often we need to do the fine tuning. How need to do pre-training and fine tuning. Okay, pre-training, that is requiring huge infra and cost, requires huge infra and cost. So and huge infra cost. I will mention the data as well, updated data. Amount of data and cost. So these are the requirement once we are going to perform the pre-training, and if the cost and infra and the data which we need to have the updated one with respect to the pre-training, then what I can say, every year or what I can say yearly, yearly or once in 6 months, or half yearly, yearly we can do this pre-training. But fine tuning that is not requiring the huge infra and cost, so it might be possible fine tuning we can do weekly, weekly or monthly, depending upon the organization. So fine tuning we can have monthly or weekly, even if the data set is not, you can say, require more accuracy and all, then you can do it daily as well, but daily is not preferred. Organizations are preferring weekly, and even some organizations are there which are preferring the monthly, you can say, fine tuning of the data, right? Fine, Swati? Is it fine, Swati? Anything else?
No, sir, fine. Thank you.
Okay, perfect. Now, what we have seen, we are going to, we have performed the fine tuning with respect to this particular approach. Another approach for fine tuning, what I can say, another approach for fine tuning. Okay, so another approach, what I can say, that is reinforcement learning, RL. RL is reinforcement learning, and sometimes it is called reinforcement learning human feedback, RLHF. Okay, so RLHF is the another way in order to do the fine tuning based upon the human feedback. With the name itself, like we are able to get say over here, if you are not happy with the answer, then you can provide the feedback, so it will ask at each and every, you can say, time we are asking something from the LLM models, it will ask a feedback. Okay, and if we provide the output, so it will consider, if we will provide the feedback, then it will consider that particular feedback, and based upon the feedback it is going to mold the output. Just have a look. Say, write a code for for or write a query, SQL query, to find the second highest number. Okay, so it will provide me the SQL query, like select distinct from column name from table. Okay, so it has given me the query. Okay, so if I provide the feedback, say how I can implement implement it in say Python. Okay, so it will provide the Python code for me. So that is nothing but say I'm providing the feedback. I can provide my feedback. It will consume more memory, more memory. So provide the output with respect to less memory utilization. Okay, okay, then it will mold the code so that the memory footprint will be less. Okay, so this is nothing but by providing the feedback, the the LLM is going to change the output, or how it is going to change the output based upon the weight. So the concept is what over here, the weight. Weights are playing a critical role. The weights are keep on changing, and the output whatever we are getting, that is changed accordingly. Okay, so that is the stuff. Moving further, one term is there, LLM agents. LLM agents. Okay, so over here, with respect to the LLM agents, what I can say, like the pre-training, this is the specialized task, and we can't do it on daily basis because this requires huge infra and cost. So pre-training is not possible on every day. So what I will do, what I will do, then this particular LLM agents concept will come into the picture. Okay, so over here we will be having the support from the external tool. So support from external tool. Let me try to mention over here. LLM model is there. Okay, LLM model plus support from some external tools, and that is nothing but LLM agent. Okay, LLM agent. So what I can say, the pre-training is not done every day, and if we want to further improve the accuracy, so what we can do, we can attach LLM model with certain external tools. You can think in this particular way, like we are having weather forecasting application. Weather forecasting application is there, and what I will do, I will attach weather forecasting with LLM model, and I will having the weather forecasting agent. Weather forecasting application. Okay, and then it will provide with the output. So what I can say, weather forecasting agent. And that is nothing but the LLM agent only. So weather forecasting agent. So with the help of this LLM, this particular data will be clubbed with the LLM output, and we will be able to get the more accurate output. You can think in this particular way. LLM agents are trained onto the past data. It is not like say it is trained onto the future data. It is trained onto the past data. So if I ask LLM model, well, what will be the temperature on 15th of July, so it will not be able to provide. Or what will be the predicted uh, temperature on 15th of July, it will not be able to provide because it is not trained based upon that particular data. So at this moment, what I will do, we are having an application that is weather forecasting application. It is clubbed with the LLM model, and if I passed this particular data from the LLM model, then I will be able to get the predicted weather, right? The forecasted weather. Are you able to get, friends? All
Yes,
of
sir.
you?
This is the
Okay. So
Yes, sir.
at this moment inside the industries, what is happening, they are trying to build more sophisticated agents, huh? You can take an example, say LLM as judge. Okay, so LLM as judge, so he will be going to solve the say crime cases, huh? Like even some lawyers will be able to take the help from this particular LLM as judge, LLM agents, or you can say law agents, you can give any name. Okay, so in this particular way we will be able to get the outcome, and what is happening, say LLM 1, LLM 2, and then LLM 3. Okay, so all of these particular models, say LLM1 has given certain output and it is acting as an input to the LLM2. Okay, or LLM2 has given certain output, it is given to the LLM3. You can take LLM agents over here as well. Okay, LLM agent, say LLM agents, okay, so LLM agents are nothing but LLM clubbed with certain third party application or external tool in order to provide the output, so LLM or LLM agents can club together with the help of LangChain. We will be going through with this particular word, or what is LangChain. That is nothing but clubbing one or more than one LLMs together. That is nothing but the LangChain. Okay, we will be going through with this particular stuff, but at this point of time, like pre-training is possible with the help of reinforcement learning, with the help of sorry, fine tuning, I'm talking about the fine tuning, so with the help of reinforcement learning we can do the fine tuning. So first piece was with respect to this, like thousands of question and answer are given in order to provide the expected output, so we can train it and we can fine tune in this particular way. Second method is nothing but the reinforcement learning. Okay, we are providing the feedback based upon the output what is given by the LLMs. So based upon the feedback, it is going to mold the output, optimize the output, and we will be able to get the more refined output, so uh, reinforcement learning, human feedback is the second approach. Third is nothing but the LLM agents, where LLM are clubbed with certain external applications, and then we will be able to get the LLM agents. When one or more agents or LLMs are clubbed together, then that is pronounced as LangChain. For LangChain is nothing but combination of more than one LLM models. Okay, fine so far.
okay.
Okay,
Got it.
so let me try to go through one practical.
LLM is only working on the text data, na?
Yes, LLM is working on to the text data,
Okay.
but GenAI is able to work onto different types of data, right? Generative AI. Okay, so we are having this in the previous session from the practical perspective. What we have seen, what we have seen. Hmm. We have done the sentiment analysis, right? We tried to find the sentiment, right? Friends, are you with me?
Yes, yes, there only, sir.
Okay, so in previous session, we tried to find sentiments based upon given sentence sentences. Okay, in today's session, we will try to summarize the try to summarize a given paragraph. Okay, so we will pass a paragraph and we will try to summarize that particular paragraph. Okay, so that we are going to do in our current session. Okay, so the same stuff, same piece of code, like say from transformers, import pipeline, we need to import the pipeline. Okay, pipeline, and then we will be writing summarize equal to, we will use pipeline, and from the pipeline I will use the specialized, you can say, summarization, and then max length I give max length say 130, and minimum length for the summary, what I want say 50. Okay, so what I have mentioned, I have imported the pipeline from the transformer. I have defined a keyword or variable summarize, and what it will do, it will use pipeline, and there are special tasks say, so summarization task I am going to utilize in the last session. We have used the sentiment analysis over here, and we are going to pass max length and mean length over here, and then say input is there, input, and say input paragraph, and let me ask ChatGPT to write a paragraph. Write a paragraph on Gen AI for me. Okay. So this is the paragraph what I got from the Gen AI. Okay, and how I will be able to rewrite it. Okay, I need to provide in this particular way. Okay, string or paragraph I need to pass with the help of this particular three inverted commas, double inverted commas, and then simply the simple step, I will pass this particular input text from the summarizer, and then I will be able to get the output. Okay, let me connect. Okay, so let me paste this particular stuff. Connected. Okay. Let me run this as well. Okay, now what I need to do, I just pass this particular, like previously what we have done. So I will have result, and I will pass this particular input paragraph, so summarizer, and I will have this particular input paragraph. Let me run it, and then I will print the result. What has happened? Max length, min length. Max length is set to 142, but only 134 since. Okay, let me try to. Your max length is set to 142, but the input length is only 134. This is the summarization task. Shorter. Mhm. Let me do without this. And print result. And let me try to copy this. Okay, and input was given to this. It has provided. Okay. Okay, so just have a look. Whatever we have given, it has provided us the summary with respect to this. Okay, it has provided the summary, right? We can pass another, you can say, uh, another paragraph, and we can change the model as well. Let me try to check the summarization models available, and we will change the model. We'll try to change the model from here, and then we will proceed with the summarization task. Uh, so let me try to write a paragraph, write a different paragraph graph in 200 words on deep learning. And on to the Hugging Face, I will try to find out the models, summarization model. Summarization model. Downloads active summarization models. T5 base. Let me take this T5 base summarization model. Okay, and what I will do, I will try to change this. So say summarize one. I'm going to change the parameter. Okay, and then I will try to pass the different model. So task equal to say summarization, and model equal to T5 base extractor model. And then I will do the rest of the stuff. Say copy, and over here I will try to add one line. Guys, please ask if you are not able to get anything. So pipeline I have imported, summarization task, and the model is changed at this moment. What has happened? Is not a local provider, valid name. Okay. T5. Model is this one. Let me try to copy this particular piece of code and paste it over here. So model is this one. Okay, summary is this one. Import T5 conditional generation T5 tokenizer. Tokenizer is this one. Model is T5 from pre-trained. Okay, so over here, this is the model. T5 conditional generation from pre-trained from underscore pre-trained, and this is the location of this particular model. What we are able to get over here, we have not specified the correct path. So because of the path, it is throwing the error. Like say T5 based summarization claim is not a local folder, it is not a valid model identifier instead. So we are not able to import it properly. T5. Let me try to check. Model T5, I think it should claim extractor. It should provide me the output. It should be able to import. Let me try to paste it once again. This is the same one only. Mhm. Classification, sorry, summarization models, text summarization model. Model fine tune T5 small. Let me try to check with this model. Mm-hmm. We are not able to import. This is not the model name. Correct model name is not given. Model name is, we have used this one. This is not the model name. Model name will be, this is the model name. This is the same code what we are using. Okay, just a minute. So just have a look over here. So summarizer pipeline summarization model is this one. Okay, text summarization. This is the Falcone SI text summarization. We will be going to use this particular model, or the same code is given. Whatever we are using, say from transformer import pipeline, then we are using this summarization task, and the model is this one, and this is the article, and then we are passing article from the summarizer, and we will be able to get the output. Just let me try to copy and paste it over here. Okay, so article is nothing, started with triple inverted commas, and it will be ended with inverted commas. This is nothing but the paragraph, and over here what we are passing the article, and article is nothing but this particular keyword, or variable, which is having this particular paragraph. Paragraph is assigned to this particular keyword. We are passing this particular keyword variable over here. Max length is this one and min length is this one. Do simple false. We can, or we can remove these particular, you can say, properties as well if you want. So let me copy this and paste it over here. Uh, uh, huh. So in the previous step, what we have done, we have imported the pipeline, then summarize is the variable which is having the task from the pipeline summarization, and input paragraph is nothing but one paragraph is given, and we have not passed any model over here, so default model was used, this one, that is SSH Leifer distill bird CNN 112-6. This is the model which was utilized because we have not passed. And transformer pipeline is the smart one. It is going to use the default one. But in the second phase, what we are going to do, we have passed the model. Okay, the Falcon SI. SAI is the model which is text summarization model we have used, and this is the paragraph at this moment, and then simply we have passed this particular paragraph, that is nothing but article, and then we will be able to print the output. So this is the summary. Okay, this is the summary what we are able to get. This is the summary text. Okay,
So
what we
here
are.
the model selection depends how we can select, like there are so many models, and like remembering every model is not possible, right? So how we will decide which model to use when?
So, so basically, what is happening? You can utilize different models over here. You can write your code in such a way that if the output of this particular model is not up to the mark, then you can use the default one, or you can have say summary 1, summary 2, summary 3, summary 4 is like this. You can have different, you can say, models. You can assign different models, or you can, what you can do, model is you can assign a variable over here to model, and you can pass all the models as a list, and you can iterate with those particular models, right? Are you able to get,
Yes, sir. So,
okay?
but like how we will decide like which model is best for the data which I'm providing?
So basically it will depends upon your feedback, okay. Over here how we are able to get, how GenAI will be able to get that this output is correct, we are providing the feedback, if that particular output is correct, then you can take it, okay. Otherwise you can proceed by, you can say, fine tuning that particular model, and how fine tuning will be done based upon the different, you can say, weights modifications, and that particular things will come into the fine tuning phase, okay. Inside the machine learnings we are having accuracy, okay, uh, and you can say F1 score and all, okay. But over here the probability is the stuff we will see. I will show you with the help of one thread. I will try to find out that I was having, but I'm not able to get it today. I was planning to show that, okay. So whatever you are typing, based upon that, the different probabilities are being generated, and based upon the probability, which word is having the highest probability, that will be given, okay. In the same fashion, based upon the probability, uh, the output is given, okay. But it will be depending upon you how you are going to further optimize it, so if it is not up to the mark, then definitely you need to proceed with the fine tuning and all, right?
Fine, sir. So one more question, like for summarization, we are having multiple models.
Mm-hmm.
So similarly, for some other task like doing some other operation onto the data, we will be having different models accordingly, right?
Yes, 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 there are different models, and for
Where we can get
summarization,
this bulk, like which model is applied to which task.
okay. So over here onto the Hugging Face itself, like, you will be able to get, say, uh, summarization, okay. So just have a look over here. There are different, say, test 1 3, bars of bath, organism. So these are nothing but the summarization models, okay. Summarization model, nurse in text summarization, okay. Or let me mention text summarization, okay. So text summarization, text summary, these are nothing but different models, which are specially for the text summarizations only, okay. Nepali text summarization, fine tune BART language, BART large model, BART large fine tuned, okay. These are the summarization model. Llama summarization model, okay. Arabic text summarization, right? So based upon the usage, your use case, you can choose a particular model, and if at the very first stage the output is not up to the mark, then you try to change it with the different model. If you are having a particular model and further you need to enhance the accuracy, so you need to proceed with the fine tuning and all, we will see how that particular thing will be done, fine tuning and all, but fine tuning, you need to proceed with the fine tuning and all, right? uh, Sentiment analysis, say sentiment, okay. So over here different models are there, roberta based sentiment, roberta based sentiment, twitter, uh, distill, BART, fine-tune financial news, okay, Twitter, Roberta base, sentiment base is nothing. This base, if like something with base is there, that means this is the foundation model. So this is the foundation model. Over here, fine-tuned. So this is the fine-tuned model. Multilingual, uncased. So different models are there. Language conversion. Language identification, language detections, Jasper, vision language. So different types of models are there based upon the specific task, and you need to pick based upon your use cases. Okay, we will go through with many more tasks like summarization. We have seen we will try to convert the language, say from Hindi to English, and English to Hindi. We will try to utilize such type of models as well. We will have different tasks, so uh, let me try to show different tasks in. Okay, text generation, image generation, audio generation, code generation, multimodal generation. Okay, a lot of type, you can say, algorithms or models are there. So based upon the use case, we need to proceed with a particular model, and text generation we will see. Okay, code generation we will not see. Language detection probably we will see. Okay, and conversion of language we will see. So these are the simple examples. I will walk you through with that. But uh, the main thing is that, like, you need to have the idea how a particular model can be used, and further, like, slowly we will be picking the pace, and we will proceed with fine tuning and all. So at this moment we are able to get the things from the top level, but we will be moving in detail, and we will be having the focus onto the fundamentals, how things are working internally. So say how the weights are being assigned and how the weights are being modified, that we will see in detail. Okay, we will go through with that particular thread that is providing, like, how a particular word is linked with the another, and based upon that weight is being calculated. So we will see those particular things. No need to worry. And what I want, you need to go through with the practicals as well. Try to create the account on Google Call app, and try to write the code, like importing the transfer pipeline from transformer. Try to use the models, default models. Try to change the models and check the output. So that you need to cover onto the upcoming days. In the next week, like, we will drill it further, and I will I will cover many more use cases from the task perspective that we can do with the Gen AI, and we will start writing a little bit more complex code. At this moment, we are having very simple code. We are just importing the pipeline, and defining a variable, and then uh, passing the given content from that particular variable. This is the simple stuff. So we will try to do it with the help of tokens and all. So in the middle, like, tokenization process is being happening, so we will try to move with tokens and all. So that particular stuff I will cover in next session. So that's it from my side for today's session, friends. If you are having any query, you can ask now. Lakshmi, Ayush, Shivam, Gaurav, Swati,
So can we
Anurag.
continue this setup on Sunday only? Just because Saturday is very tough to join.
Come again.
I'm saying, can we do this training in Sunday only? Just because Saturday is very tough to join.
So dear, the course content is huge, and only one day in a week you will not be able to cover in 6 months. Huh? So my
Okay.
main motto is try to go through with all of these things within 3 months. And what I can do, you please go through with recordings, whatever will be covered in on Saturdays. So if you are having any doubt, post session on Sunday, we can have discussion on that. Huh?
Sure, sure. Thank you.
Okay. Okay, guys. Then take care. Huh? Have a good day.
Thanks, sir.